In number 9, 9 was the one of the two problems that you had to do the calculus, and I started you in the middle, meaning that because I gave you the equation for velocity, you'd have to use the derivative to get one of them and use the integral to get the other one. So the easiest one is probably the acceleration, so let's start there, because the acceleration is just the derivative of velocity with respect to time. And you know, you had to show me some work. You had to show me where the number came from. Maybe I give you more credit than I should have, but show work. In fact, on some of these I said show work or no credit. You can't just write down whatever. You've got to show what the work is. Now in this problem, since I'm taking the derivative of this one with respect to time, well, the derivative of sine is cosine x dx. So I'm going to get, if I start writing this down, I'm going to get first minus 24. Now the derivative of sine is cosine, not negative cosine. So I don't have to change the sign. It's still going to be cosine 8t, but then times the derivative of 8t, which is 8. So if I combine the 8 and the 24, I get negative 192 cosine of 8t. So that was half of the problem, was to get the acceleration.
So you don't, I thought when you found the derivative that you had to cancel out the variable. Like when I was attempting to solve that one.
No, not when when it's a trig function, the derivative of if it's a polynomial equation, you reduce the exponent by 1, but the derivative of a trig function is just another trig. Like the derivative of sine is cosine. The derivative of cosine is minus sine.
So as long as sine or cosine is there, you're not going to cancel out any variable.
Right.
Okay.
If anything, you're going to end up adding, like, for example, the equation is cosine x. It's like the derivative is sine x dx. And if I'm saying my x is 8t, then my dx is the 8. It's the 8 part of it. Okay, now, to go in the other direction, we have the velocity, and I have that velocity is the derivative of, now I can either write that derivative of x with respect to time if I'm saying that it's moving along the x-axis. I can say dy with respect to time if it's moving along vertically along the y-axis, or I can use the generic s, which is what I used when we did straight line motion, that s was our symbol for displacement. So it would be the same thing as for position. So since I know v and I'm looking for that, I'm going to rearrange it and write this as ds equals v dt. So I'm going to write it like that. ds equals v dt. And then I'm going to take the integral of both sides. So I'll take the integral of each one. So the integral of ds is just going to be s. So we now will be solving for what we're looking for, the position in terms of time. Now for v, I'm going to go up here, and I'm going to write this in for my v. But the negative 24 I'm going to put to the left side of the integral because it doesn't affect it. I want this part. So I'm going to write, it's going to be minus 24 integral of sine 8t, and then look, 8t dt. So I need a dt there. Now here's the problem. My equation for the sine of x, dx, there has to be a dx. Like it can't be the integral of sine x. It's the integral of sine x dx. All right? Both of those have to be there because remember, what an integral represents is it represents an area under a curve. So the sine x really represents the height of my rectangle, and the dx represents the base. And I'm just adding up a whole bunch of them between some starting value and some ending value on the x-axis. So I need both of these in order to say that the integral of that is going to equal minus cosine x. Like that's what the result is of that. So if you look at my equation here, I have, that's my x. So x equals 8t. That's what x is in my problem because I want to match it up with what will go in. Well, if x is 8t, then I know that dx dt, if I take the derivative of x with respect to time, it's going to be 8. Now, so dx, because I don't want, notice right here, this is not dx dt, it's just dx. So I don't want the dt. So if I move this up, I'm going to get dx is 8 dt.
Wait. Oh, yeah,
So what I need, so if you look at my equation here, if you look at this, I have sine x, but I don't have dx. I only have dt. So I still need an 8 so that this represents dx, because I need dx. So I want that to be dx. So dx is 8 dt, so that means that I need to multiply by an 8 so I have everything there. So that I have the sine x dx. This whole thing is dx, and that's x. So that way I'll be able to use this formula and just, put in what x is when I solve it. But if I'm going to multiply by 8, you can't just multiply by 8. You also have to divide by 8 so that I haven't changed the value of what I had there. If I'm going to multiply by 8 over here, I'm going to divide by 8, so I really didn't change the value of what I started with because I'm basically multiplying by 1. 8 over 8 is 1. I'm just putting it in places just to make it so that it fits my integral. Yes?
Why wouldn't you just, instead of multiplying, why wouldn't you just make dx over 8
Because that would equal dt. I mean, if I'm not trying to, no, I mean, look, this is my generic formula for an integral. Sine x dx. I want whatever, every problem isn't going to happen to have an x, and this one doesn't happen to have an x. It has an 8t. If that's what my x is, then I need what the derivative of that is as part of this so that I can then take the integral. I can't take the integral unless it has everything there. It can't just have the sine x and not have the dx. So I need both parts there, and this was incomplete the way it was originally shown. When I plugged in for v and then the dt, it was missing the entire dx, so I had to plug that in. So now once I get to here, I'm just going to solve. So negative 24 divided by 8 is negative 3, and now I'm going to take the integral of sine x dx. Well, it's minus cosine x, so it's going to be minus, which is going to make that a plus, cosine of x. Well, my x is 8t, so that's 8t. Now, anytime you take an integral, and it's what's called an indefinite integral, meaning that I don't have a starting or an end point, there's always the possibility that there's a constant. So usually we will write in plus c, because there might be some constant that would disappear if we actually took the derivative of this to try and get back. Like with this equation, I should be able to take this and take the derivative and get back that. Because if the integral of v gives me s, then the derivative of s should give me v, because it's just going in the other direction.
Would you get points off if you forget to write c?
No, I didn't take off points if you didn't write c.